In this video, we're going to start discussing a new topic, polar coordinates. So what I always say about polar coordinates is that they're just kind of a different way of describing the same idea that we were always used to in like X and Y world. So, at our school, the gym is a little bit separated from the main part of the school building, and frequently when I go outside, I have somebody like flag me down and like, hey, how do I get to the gym? And what I always say to students is like, on one hand, I could tell that campus visitor, I could give them the latitude and longitude coordinates of the gymnasium and, hope that they have a smartphone that in the ability to copy down all those decimals, right? Or I could say it's about half a mile over there and point towards it. And to those campus visitors, about half a mile over that way is far more helpful than, the exact latitude, longitude coordinates of the gymnasium. And so I would say the exact latitude, longitude coordinates of something that corresponds to like X and Y, rectangular coordinates, whereas polar is the about half a mile over there, each useful in their own context. Before we go into the conversion factors, I just want to take a second and go back to the meanings of x and y and really be specific about the meanings of r and theta. So we've got a point in the plane, okay, and we're used to describing it with the coordinates x and y, where x is over here and y is right there, right? And if we think about the meaning of x and y, what really the coordinate is the horizontal displacement from the y-axis, and the y-coordinate is the vertical displacement from the x-axis. Okay, and so, I think about, x is how far over I went, right? That is the same as that. And y is, how far I went up, which happens to be, that same distance right there. Now in polar coordinates, we're thinking more radially, like from the origin to the point, what direction and how far. So r, like the radius, is the distance from the origin, and theta is the angle like it works in the unit circle. And what I told people in my class is you already know how theta works. That's like probably the one thing that you're going to be most familiar with when we talk about polar coordinates. No, for the fundamental identities or the conversion factors, what we're trying to do is, write formulas for x and y in terms of r and theta, and then write formulas for r and theta in terms of x and y. And so we're just going to have to be looking at this triangle, thinking critically, like, what do we know is true on this right triangle? Hey, really what we're thinking about is the tip of that angle that has measure theta, that's at the origin, and the point at the top of the triangle, that's going to be the point x, y. That's really what we're thinking here. Probably should have drawn that in, but too late now. So, thinking about x, what's a formula that relates x, theta, and r? That would be cosine, right? Cosine of theta equals adjacent over hypotenuse. So we could solve for x and get a formula with r and theta in it by multiplying both sides of this equation by r and getting r cosine theta. For y, in terms of r and theta, same idea, trig. Okay, theta, r, and y, that's going to be sine. Okay, sine of theta equals y over r, multiply both sides by r, get y equals r sine theta. Then, okay, r in terms of x and y, three sides of a right triangle, Pythagorean theorem, x squared plus y squared equals r squared. And used to, I would say r is the square root of x squared plus y squared, but I think, in this class we need to be ready for when r goes negative and thinking about what happens there. So I'm just going to leave it there. Say r squared equals x squared plus y squared, that'll always be true. And then theta is going to be, okay, theta with x and y, that would be tangent. Okay, so tangent theta equals y over x. Theta is going to be inverse tangent of y over x. Now I will tell you that, because of the way the arctangent works, okay, it could be arctangent of y over x plus pi if x was negative, but I really, like, that's an extremely fringe situation. These are the formulas you need to know. I think you'll see, my advice for theta is just use your eyes, and use your eyes, trust your heart. Like, you know what theta is. That's like I said earlier, that's probably the one thing you're really good on. Okay, so just to start, if we were asked to give a sketch of the point in rectangular coordinates, okay, this means that x equals 4 and y equals pi. Okay, so that's going to be my sketch of the point. Because that's rectangular is x and y. I think that's probably what I would write. X equals 4, y equals pi. We just know that x comes before y. Okay, in polar, you need to know that r comes before theta, and that's going to seem backwards, especially once we go in and start to graph these functions, because r is going to be the output variable and theta is going to be the input variable. But we think that this is because of, alphabetical order, but it's very important that you look at this point, and if it says polar coordinates, you know that 4 and theta means r equals 4 and theta equals pi. That's going to matter. Okay, so giving a sketch of the point, okay, giving some axes. Okay, you know where theta equals pi is. It's over here. Okay, and r equals 4, that would be 4 units away. Let me get that a little better. Okay, there we go, 4 units away from the origin. Okay, that's the point 4 and pi. Okay, because I'm thinking about theta equals pi on the unit circle, I'm going in that direction, positive 4 units. Okay, now let's talk about what would happen if r was negative. Okay, if we are over here, and I'm just going to go, okay, give a sketch of the location in polar coordinates. So this is r equals -2, and theta equals pi over 2. And in class, I was successful. I don't know how much of it was me just like really, really hinting at it, and how much of it was people really seeing what was going on. But what I'm saying over here is that, we're going towards theta equals pi over 2, which we know is straight up. And we're going -2 units along that way. Well, okay, so if positive 2 units is up there, -2 units is going to go backwards from the origin, right? 2 units away from the origin in the backwards direction. That's what -2 means. And so we're going to go back here to -2. I guess I was coloring the point in black. And that's going to be the coordinates of the point. Okay? Negative radius just means go backwards from the trajectory you expect based on theta. All right, here's one I think you should try on your own. This, once again, it's r and theta in polar coordinates, so r equals -1 along theta equals 2 pi. I'm going to draw the x and y axes, but I want you to, on your paper, or whatever you're taking notes on, or whatever, just if you're thinking about it, think about where you expect this to be. Okay, if you're sketching, go ahead and do that with video pause, because I'm just going to bring in the answer here in just a second. All right, there you go. It's over here towards theta equals 2 pi, -1 units in that direction, so I go backwards 1 unit, and I'm going to be over there where x is -1 and y is 0. This is one that doesn't have a negative r value, but it does have a negative theta, so theta is -2 pi over 3. I think I'm a little too zoomed in here. Yeah, there we go, and then I will sketch an xy plane. Okay, we know where theta equals -2 pi over 3 is. That would be kind of down here, maybe. And 3 units away, so that would be 1, 2, 3. And the point would be right there, and somewhere in the third quadrant down. Right, that's as good of a sketch as we've got without a grid. For this next one, I've got r equals -5 and theta equals 1, so I thought this was a little bit different. Okay, theta equals 1, that's 1 radian. And so what you need to think about when you see a number like that is like kind of what is it close to in the unit circle world. Okay, well, we know pi over 3, we know where that is, and pi over 3, that's 3.14 divided by 3, that's really close to 1. Okay, so I get my xy axes and I draw out, okay, theta equals pi over 3. But if I want negative radius, I'm going to need to go backwards from there, and I'll go down into the third quadrant. So I need to extend that line, pardon me, that way, and think about going backwards 5 units. I'm going to make 1 unit not super far on this one. 2, 3, 4, and then 5. I'll make that one a little bit bigger. And those are supposed to be like little bits of a circle, because that's really what we're going to be doing. If, once you get on a polar grid, once you're given that, I'm intentionally not giving it to you at first because I'm trying to build the intuition. And once you're given that, you're going to be counting out some number of circles away from the origin. Now I need to tell you something about polar coordinates. They are not unique. Okay, so for a given point in the xy plane, there's only one set of x and y coordinates that describes that point. But that is not the case for polar because of the repetitiveness of the unit circle. So a point like 10 and pi over 4, okay, that's really not going to get the job done. Okay, 10 and pi over 4, 10 units away from the origin along theta equals pi over 4. So I'm just going to say, okay, that's a distance of 10 right there. Okay, that's going to be the same as if I said, okay, well, r equals 10 and theta equals pi over 4 plus 2 pi, right? I just go around the circle one more time. So I could say 10, and 2 pi is 8 pi over 4, so I'd be adding to 1 pi over 4, 9 pi over 4. That would be giving me the exact same point, right? I'd just rotate once around the circle again and be right back there. Okay, but I could also look for one with a negative radius. Okay, so negative 10 would be along, kind of back here, and over there at a 45-degree angle into the third quadrant, that's 5 pi over 4. So I could say negative 10 along 5 pi over 4. I'm not sure why I would want to, maybe except for I was requested to write two different pairs of polar coordinates, and I was asked to make one of them having a negative r value. And I think that's a problem you're going to see on the homework. Then for negative 2 and 3 pi over 2, maybe I'll just kind of zoom in on this one. Get a y-axis and an x-axis. Okay, so we're going towards 3 pi over 2, negative 2 units, so back this way. And we want two other polar coordinates. Well, a more sensible polar coordinate for this would be 2 and regular pi over 2, positive 2. I could say 2 and 5 pi over 2. But I could say negative 2 and call 3 pi over 2 negative pi over 2, right? That would work also. And, yeah. Now, I don't want you to think that you can just take a given set of polar coordinates and multiply both of them by negative 1 and get something that's equivalent. That's more of a coincidence about kind of the way that pi over 2 is working. The last, example type that I've got for you for this video is just converting coordinates back and forth between polar and rectangular. So this first one, here's some rectangular coordinates, give me the polar coordinates. And with this one, I recommend that we use the Pythagorean theorem and our eyes. But going polar to rectangular, I'm going to recommend we use the formulas. Okay, and I think you'll see why. So that's not really what I'm going to want at all, is it? I'm going to want x is 5, and oh my goodness, y is negative 5 root 3. Negative 5 root 3 is going to be more negative than positive 5 root 3 is positive, so I'm going to draw it pretty exaggerated, so it's down here. Looks like theta's, okay, if I've got a root 3, I know it's a 30, 60, 90 angle, and if it's got to be one of the two, now this is going to be 60 degrees. So I'm going to say theta equals either negative pi over 3 or 5 pi over 3. And as far as r, the distance from the origin, r squared equals x squared, which would be 25, 5 times 5, plus y squared, which would be negative 1 squared, times 5 squared times square root of 3 squared. Okay, so 25 and 75 is 100, so r squared is 100. R could either be 10 or negative 10, but in this case, since I'm thinking about going towards 5 pi over 3, that would be r is positive 10. Okay. And the second one is x equals negative 8, y equals positive 8. So I'm going to need kind of this one. Okay, but this, over here, this is just one possible set of polar. It didn't like that shape at all, did it? This is just one possible set of polar coordinates for this point. There are, many others. So negative 8 here, positive 8 there, so that means that I'm working on a 45, 45, 90 triangle. Let's go ahead and draw my best effort at a 45-degree angle. Looks pretty decent. And I'm going to say it's about there. And so this is, using my eyes, I can see that this is just short of pi by pi over 4. This is 3 pi over 4. No need for, arc tangent of negative 1 plus pi. That is 3 pi over 4, okay? But we don't need to get into that, right? Because the type of points that we're needing to convert correspond to the special right triangles, and we have the ability to just draw the diagram. We've done that work so far this year. It's why we did so much of it. So that, later on we could just use these results, and 64 plus 64 is 128. Okay, so I'm going to actually just call that 2 times 64, and because that would be how I would be splitting it up to take the square root anyway. And so I'm going to say r is equal to the square root of 2 times the square root of 64, so that's going to be 8 square root of 2. So r equals 8 root 2. It could have been negative had we done theta equals negative pi over 4 or something like that. But we're going to say r is positive and theta is what we expect because it didn't ask us to do anything crazy. Okay, now these other two I think would be good for you to try on your own. Yes, this would be a good idea. So try this one on your own with video pause. I'm going to bring in my solutions here in just a few seconds. All right, there you go. So I got r equals 8 and theta equals negative pi over 4, and r equals 3 and theta equals negative pi over 2. You might be there thinking, well, I got r equals 8 and theta equals 7 pi over 4, and r equals 3 and theta equals 3 pi over 2. And that's great. That's just as right as I am. I just want to really hammer home that like the polar coordinates of a point are not unique and that there are many different coordinates that name them, oftentimes with just like kind of manipulating theta. I would also point out that negative pi over 4 and 7 pi over 4 are coterminal angles, and so are negative pi over 2 and 3 pi over 2. So, these are my answer and your answer would both be right in that situation. Okay, now for polar to rectangular, I in general recommend that you use the formulas that I copied down on screen. X equals r cosine theta and y equals r sine theta. And those are formulas that we definitely need to know. But sometimes when theta is like one of the big stops on the unit circle, I don't think that would be necessary, right? Because I know you know where theta equals 2 pi is. It's over here to the right. And if I go right 10 units, I'll be right there at the point where x is 10 and y is 0. Okay, so we can just do that. We're going to say x equals 10, y equals 0. If we know where we're going and what we're doing, we don't need to use the formula if we don't have to. Maybe something like r equals negative 4 and theta equals negative pi over 6, that might be the type of thing we should use the formula for. So I'm going to draw a trig diagram for theta equals negative pi over 6. Not very far down. Okay, so this would be negative 1/2 on the 30, 60, 90 triangle. Would be 1, and this would be positive root 3 over 2 because I'm over there in the fourth quadrant. Okay, now for x, I'm going to need x equals r times cosine of theta. So that's root 3 over 2. And that would be negative 2 square root of 3. And then y is going to equal r sine theta. And that would be negative 4 times negative half. That's going to be positive 2. It's like, okay, well, the coordinates of the point are x equals negative 2 root 3 and y equals positive 2. And you might be like, well, on your diagram, you're over there in the fourth quadrant where x is positive and y is negative. What happened? Well, that's the r being negative, right? That's going to extend me back up there 4 units up into the second quadrant where x is negative and y is positive. So I think that was just point that out. I thought that was a good example on that front. Okay, now r equals pi over 4 and theta equals pi over 4. These are going to be kind of like strange ones, these last two, but I feel like I need you to be aware of these also. Okay, remember x equals r cosine theta. So pi over 4 multiplied by cosine of pi over 4. And you know what cosine of pi over 4 is. If the pi is over 4 is some kind of root 2 over 2. And in the first quadrant, they're all positive. So this is going to be root 2 over 2. And y is r sine theta, pi over 4 times, sine of pi over 4, also root 2 over 2. And, so I have the coordinates pi root 2 over 8 and pi root 2 over 8. That's kind of a strange example, okay, but definitely something you could be asked about. Okay, and then r equals 5, theta equals 2. Theta equals 2 radians. Here's another one of these weird theta locations that we're not familiar with. Okay, and this is really where I just have to emphasize the essentialness of how important it is that you know the formula, right? Because in a multiple choice situation like this, you're just going to have to know that x equals 5 cosine of 2 and y equals 5 sine of 2, and there's nothing more that we can do with that because we don't have any special right triangles that correspond to 2 radians. Okay, so that's as much as we're going to be able to say about this point. We could put it as a coordinate pair. but we're not going to be able to do, oh, whoops, I forgot to say 5 cosine of 2 and 5 sine 2, but that's all we're going to be able to do. And that's all I've got to tell you for this video about polar coordinates. I'm going to come back in another one and tell you about complex numbers in polar coordinates, but that'll be a separate video, and you can probably click around somewhere and get access to that right now. But that'll be all for this one. Thanks for watching.